Most people hear one name when it comes to AI hardware: Nvidia. But there's another story, one that begins in Beijing and explains the global chip race from a very different angle. This is the story of Cambricon Technologies, a company born out of a research lab trying to build China's answer to Nvidia. It's not just about chips, it's about ecosystems, geopolitics, and the future of artificial intelligence. Cambricon started as a research project inside the Chinese Academy of Sciences, focused on brain-inspired processors for deep learning. In 2016, brothers Chen Tianxi and Chen Yongji spun the project into a company called Cambricon Technologies. The name Cambricon comes from the Cambrian explosion, the moment in Earth's history when countless species emerged rapidly, a metaphor for the explosion of neural networks. One of Cambricon's first major breakthroughs was with Huawei. Its Kirin 970 smartphone chip shipped with a neural processing unit that Cambricon co-developed. This was one of the earliest NPIs to appear in consumer devices, putting Cambricon on the global radar. Although Huawei later shifted to its own in-house designs, that collaboration gave Cambricon credibility. In 2020, the company went public on Shanghai's stock market, raising hundreds of millions of dollars. That IPO turned it into one of China's flagship AI hardware players. But the geopolitical climate shifted fast. By the end of 2022, Cambricon was added to the U.S. Entity List, cutting it off from American technologies and high-end foundries. Suddenly, its mission wasn't just technological, it became political. What does Cambricon build? Its products are branded C1, or MLU short for Machine Learning Unit. Over the years, they've released several generations. MLU 100 in 2018, their first data center accelerator. C1 270, designed for both inference and training, shipped with their early software stack. C1 290, a 7-nanometer chip with tens of billions of transistors, built for full AI training workloads. And C1 370, their first chiplet-based design, with around 39 billion transistors. It can hit over 250 trillion operations per second for INT8 workloads and more than 20 teraflops of FP32 performance. It scales with Cambricon's own interconnect system called MLU Link, which allows multiple cards to talk to each other at high bandwidth. But silicon is only half the story. Cambricon developed its own software stack, Newware, along with programming tools like Bang and Catch, a PTorch backend. This stack is their equivalent to Nvidia's CUDA. It allows developers to compile models and run them on Cambricon hardware. Without it, the chips would just be raw silicon. They also designed full systems multi-accelerator boxes with MLU Link interconnects, marketed as training solutions for domestic data centers. And despite years of losses, Cambricon reported its first quarterly profit in late 2024. Thanks to rising demand in China as U.S. restrictions limited access to Nvidia GPUs. Now, let's talk about the policy backdrop. Cambricon's trajectory can't be separated from politics. The U.S. Entity List action in 2022 directly blocked its access to advanced U.S. chip design software and leading-edge foundry services. At the same time, the U.S. restricted Nvidia from selling its most powerful GPUs to China, creating a vacuum. Chinese companies that couldn't import A100s or H100s began turning to local alternatives: Huawei's Ascend chips and Cambricon's MLOs. In short, export controls turned Cambricon from a challenger into a necessary supplier inside China. So how does Cambricon compare to the U.S. heavyweights? Nvidia remains the benchmark. With its new Blackwell architecture chips like the B200 GPU and the GB200 Grace Blackwell superchip, they combine raw performance with the CUDA ecosystem, NVLink interconnects, and full rack-scale solutions. Cambricon's MLU 370 delivers respectable throughput for training and inference. But Nvidia's ecosystem is a decade ahead, and its performance on FP8 and FP16 workloads is unmatched. AMD's MI300 series and its successors, Mi-325 and Mi-350 brings strong performance with advanced memory technology like HBM3E. AMD is catching up quickly, with its ROCm software ecosystem making AI model portability easier. Cambricon doesn't compete with AMD on global markets. Instead, it focuses on China's first deployments where availability is more important than raw power. Intel's Habana Gaudi accelerator emphasizes price performance, with competitive throughput and transparent cost per training job. Its Ethernet-based scaling makes deployment flexible. Cambricon answers this with MLU-Link and domestic integration. But its pitch is less about global cost efficiency and more about sovereignty. Grok built a specialized chip called the Language Processing Unit, optimized for low-latency inference of large language models. It excels in throughput and tokens per second. Cambricon's chips are general-purpose, not single-minded like chips from Grok. They aim for balanced training and inference within the Chinese cloud ecosystem. Cerebras took the radical path with wafer-scale chips. Its WSE3 packs trillions of transistors and nearly 1 million cores, collapsing a cluster into a single massive die. It's designed for extreme training workloads. Cambricon, by contrast, uses conventional chiplet designs, scaling with multiple PCIe cards and interconnects. Pragmatic versus Moonshot. Samba Nova focuses on enterprise inference with its dataflow architecture and 3-tier memory system. It sells turnkey racks designed to run enormous models efficiently. Cambricon's offering is more general, aimed at domestic data centers rather than specialized enterprise deployments. Bottom line, Nvidia owns the global crown with performance and software. AMD is catching up fast. Intel competes on value. Grok and Cerebras target niches with radical designs. Samba Nova emphasizes enterprise deployments. Cambricon's role is to supply a good enough domestic solution in China, one shaped less by raw benchmarks and more by geopolitics. So is Cambricon China's Nvidia? Not exactly. It's China's Cambricon Technologies, a company building parallel AI infrastructure for a parallel market. In the late 2020s, that might matter as much as performance itself. Because the chip race is no longer just about teraflops. It's about who controls the supply, who controls the ecosystem, and ultimately, who controls the future of AI. Thanks for watching. If you liked this video, consider subscribing and check out my other videos.